Hello. So this is the Diels Alder reaction. It's one of my favorites. It has sort of a fun arrow pushing mechanism. And the simplest version of it, and always the first example that we're going to see, is just the least number of carbons just making a six-membered ring. So no matter what the Diels Alder reaction is, though, we're always making this six-membered ring with at least one pi bond left over. And so for our mechanism, you can start in either direction, really. But it's three arrows, right? These pi electrons now forming a new bond, right? That new bond between these two carbons, right? These pi electrons from the alkene forming a new connection here, right? That completes the ring with these two arrows, right? But moving these electrons over to this carbon is going to mean these pi electrons have to move over as well, forming that alkene. So it's kind of a fun, elegant mechanism with three arrows. They can get more complicated though, and here's the trick I like to use to kind of keep track. For a slightly more complicated version, drawing the products can be a challenge, but here's what you do. So it doesn't matter where you start or how you number it, but these 6 atoms are involved. Let's number them. Even if you think you know what you're doing, it never hurts to number these things. All right, so give them 1 through 6. I've started up at the top here as number 1, so my products, right, here's my 1 through 6. Right, so that just helps you keep track of where all these atoms are, because this Diels Alder reaction on its own is not really that favorable. It takes really high temperatures or pressures. It doesn't work super well with all these neutral, not terribly reactive pi bonds. Usually there has to be some other pieces around, electron withdrawing groups and donating groups, to help make these reactions go faster. Here I've drawn one with 2 rings involved, so there's a lot of extra stuff. But if we're trying to draw the product from this reaction, the numbering will really help. So again, we're only focused on identifying the parts of the reaction that we really need to use. Right, so this is going to match up with our ethene, our double bonds here, and then these 4 are going to match up with these 4 here, and so let's number them again. Right, not numbering everything, just numbering the part that does Diels Alder, right? So then those 4 and these 2, we know we're going to make this ring. So every Diels Alder reaction is going to make cyclohexene, basically, and then everything else is just attached to it, right? So this was my carbon 1 on the top, 2, 3, 4, 5, 6. And then I just figure out where everything else is to draw this structure. So let's start with 5 and 6, because that's relatively easy. So these 2 carbons ended up here, so that means the rest of this ring goes along. So 1, 2, 3 more carbons. So I've made this bicyclic compound from part of my Diels Alder, right? So I've completed those 2. These are a little harder, right? So in between carbon 1 and carbon 4 is 2 more carbons, right? Just CH2s, kind of bridging over the top. These can be a little more complicated to draw, but if we're not worried about being careful and making these pretty, just say, okay, so I got a bridge between 1 and 4 with 2 bends. So just go 1, 2, right? So there's a carbon here and a carbon there. Right? And then I've got my structure. And so, keeping track of all those little side groups becomes a whole lot easier if you know to make the cyclohexene, and then if you number it to keep track of where everything goes. That's my recommendation.